next step in talking about circles is talking about central angles and arcs that are formed by radii in the circle. So let's just go ahead and talk about the definitions, and let's get that over with them so we can actually get into some examples of these. A central angle is formed by a vertex as the center. So in this example here, C would be the vertex. It's the center of the circle, and it's formed by the sides of two radii of the circle. So CA and CB would be two radii of the circle. So one side is CA, that's one radius, and the other side is CB, that's the other radius. And so you have a central angle, and that central angle would be this piece right here. Okay? And we could name another angle or major angle, but typically, as we said at the beginning of the course, we're always talking about the smaller angle or the minor angle unless we state specifically that it is. So a central angle of a circle is formed by the vertex, and the two sides are two radii of the circle. Okay? Arc. A central angle separates a circle into two parts. Each one is an arc. The degree measure of an arc is equal to its central angle. Okay, what in the world does that mean? If you'll notice, the circle, okay, or the collection of points that form the actual circle, the round thing we call a circle, whenever we put the central angle in there, it separates it into two pieces. We have an arc called AB, that would be arc AB, okay, and then we'd also have an arc over here of ADB. Okay? So we have another arc that goes around the other way that is called ADB. Now notice that the minor arc, we'll talk about that in just a minute, which is less than 180 degrees, we only need two letters. We could use three letters if there was a letter in there, but we only need two letters, and that's just the two endpoints of that central angle or of that arc. Okay? Now, if the arc is greater than 180 degrees, then we need 3 points to let us know that we're going backwards, or we want the major arc or the big part of it. Okay? So the arcs are the actual pieces of the circles. Okay? Now, the degree measure of an arc is equal to its central angle. Okay? So the degree measure of an arc is equal to its central angle. So basically, the degree measure of arc AB would be equal to angle ACB. Okay? Would be equal to angle ACB. All right? And the degree angle of arc ADB would be equal to the major angle ACB, or coming around this way. All right? Would be equal to that. Okay? Or we could also say this would be equal to 360 subtract the measure of AB, arc AB. You notice we put a little arc over it, little arch, rainbow type thing over that, and that denotes an arc. Okay, and arcs can be three different types. We can have a minor arc. It's an arc that measures less than 180 degrees. It's named using the endpoints of the arc, like here, AB. We can also have a major arc. It's an arc that measures greater than 180. It's named by 3 points, the two endpoints, and another letter on the arc. Okay? All right? As this one is right here. This would be a major. Major arc. This would be a minor arc. Okay, and there is another type of arc that we can have. It's a semicircle. It's an arc that measures 180 degrees exactly, and it's formed by diameter. And it's named by 3 points, the two endpoints, and another letter on the arc. Well, why 3? Well, because we don't know what side of the circle you're talking about that you want to include in that arc unless I have a third point that's on that side, because the two diameters simply sit there and say, oh, I'm going to split this circle into two semicircles. So you actually have two semicircles, so we need a third point that would define and tell you exactly what side of the circle you're talking about. Okay, those are central angles and arcs. There's a lot of information there. This is new. It's fairly simple, straightforward, but like everything else that we've done in geometry, we start pretty simple. Yesterday we just started by going back over diameter, radius, and circumference, pi, and the equations for that, introducing a word called chord, which we'll use here on our next section. But those are the basic concepts of central angles and arcs. We'll go into some properties here next. The properties of central angles and arcs that we want to go over, we've already mentioned some of them. There's 5 of them. They're pretty boring, but they're also very critical and essential to working with central angles and arcs. First one is the sum of the measures of the central angle of a circle with no interior points in common is 360 degrees. That means if I have a series of adjacent central angles that do not overlap, and there's no gaps in them, and they fill up the whole circle, then they're going to equal 360. Why? Because what's the degrees of a circle? 360 degrees. That should make some common sense. If I fill that entire circle up with central angles, and I don't overlap, and I don't have gaps, then the sum of all those measures of all those central angles will be 360. Now the degree measures of the arcs created will also be 360. Number 2, the measure of a minor arc equals the measure of its central angle. We've already stated that on the prior clip, but that's number 2. The measure of a minor arc equals the measure of its central angle. Number 3, the measure of a major arc is 360 minus the measure of the minor arc. Okay? Minus the measure of the minor arc. So, if we have a major arc, we take the minor arc, subtract it from 360, and that should get us the measure of that major arc. Number 4, 2 arcs. Let's make those arcs. 2 arcs. Two arcs are congruent if and only if their corresponding central angles are congruent. 2 arcs are congruent if and only if their corresponding central angles, symbol for angles, are congruent. Okay, symbol for congruent. Alright, makes sense. Congruent central angles, they have to have the same measure. Okay, congruent arcs, they have to have the same central angles. Okay, 5. The measure of an arc formed by 2 adjacent arcs is the sum of the measures of the 2 arcs. Okay, if I have 2 adjacent arcs, and I know each of them, and I want to know what the total of them are, then I just simply add them together. Now we had the segment addition postulate, we had the angle addition postulate. This is known as the arc addition postulate. Another AAP. Let's not get that confused with an angle addition postulate. These are the 5 properties that we'll be dealing with central angles and arcs.